Greetings, everybody. This is Daniel speaking, and welcome to the What's New webinar. And this will be part 4. And in this webinar, I'll show you mainly the new things, what we introduced to our 2025 version, which has been around for some time. And my job will be to show you what are the things that we have implemented inside the toolkit, a little bit MCO, and also we have in our invitation letter, we also shown there that will be a bonus where we are going to show a couple of things that we have added inside our post-processor options. Now, when I was preparing this webinar, I was thinking about let's make this webinar a little bit different. And I would like to start actually from the bonus, showing you what are the things that are new inside a post. Now, not really like a hard coding or anything, but just a couple of options that I think you will find it very interesting and you will start using immediately. So let's jump into it. I hope everybody can see it. Yes, you can see my screen perfectly. So I'm going to use in this demonstration a Swiss type machine and also kind of test Swiss type part for this demonstration. And my first feature that I want to show you, it's about automatic creation of the coordinate system. I think this is very important, especially in the military machines, very advanced one like the Vinamine, Bumatech, some 3 channels machines, maybe with 3 tables, that very oftenly happen that during the creation of the coordinate systems, you usually need to create, and you want to speed up the process by creating additional coordinate system on the first side, but also you would like to do it also on the second side over here, and you want to happen that flawlessly. Now, from time to time, and from actually depending on the kinematic that you are using of your post, this coordinate system definition will not actually go so smooth, and for some strange reason, an unknown reason to you, maybe sometimes we will create 3 max, sometimes even in different orientations, and it was very difficult to follow this, how to solve it. So for all of you that you don't know, you can go to the tools, SolidCAM, and over here you'll find the SolidCAM settings. And over here you'll see here under the CAM part, we have something called automatic CAM part definition. And I will recommend that everybody use these options as much as possible whenever you are creating the part. It can really minimize your input and maximize productivity. And I very often use this create a machine setup, and over here I use create coordinate system and also opposite side of the pod. Now, if I just keep these settings on, I will start creating my new mill turn project. And I'll want to show you this result that I have with my post-processor here. So I will approach just classically, nothing so fancy here. I will just use the Torno Swiss GT26. I'll also later show you kinematic about this machine. So I'll just click on this cylinder, and you can see that my master coordinate system has been defined here. Remember this, when I say this master or the first MAC, it's very important later in my further explanation of how to create other MACs. So for now, I'm just going to create OK. And once I click OK, SolidCAM is going automatically now to create another MAC, but you can see also that MAC 3 has been created for some reason, also different orientations. And this is something that I was not a fan of it. I didn't really like how the automatically it works. I was expecting only 2 max, certain orientation, and in majority of the cases, this was the end result. I can go to the coordinate system here, and you can see the 3 max. So usually I was just removing the third one, and just it was additional effort for it because this one has 3 tables and etc. Now I will just exit here and completely close this project now. And instead of, I will just again open the same part that I have here. But this time I want to show you how you can actually completely affect to the output of these coordinate systems. For this, you can go through Windows Explorer, and I prepare here this post over here, and I'll open the VMID file. I'll open it under the SolidCAM 2025. And for the first time now, for a couple, oh, it's here. So over here in the working style, this is something that every user can have effect on. You can modify this page as much as you want. And to control these things, we have created something here that is called coordinate system. And here, there's an option of auto create settings parameter. These are the three dots that you can find it here. And by double clicking on this, you can see the window additional will pop up. And every post-processor will be converted like so. This field will be completely empty, which means that old engine works as it is. So all the results that you had in the previous version will continue in 2025 version, as long as you have these settings like not defined. But what you can do is that on top of your master mag that it's creating, you can create additional mag on top of this. So how to do that? Just simply clicking on one here. You can add additional ones as much as you want, but for this machine, I just need a single additional coordinate system. So the end result of this, I'm going to have Mac 1 and also Mac 2. And this would be the matrix for it. So my first one, the matrix that actually I want to say is here I have the part. So this was my master one, right? So this was my master one, and I would like to create here the second one. So this is around my X, and this was my Mac 2. So I want just another one to be created on the other side of my part, and I want to be rotated for 180 degrees around my X-axis. So I'll do that. I'll just say opposite side of the part, yes, please. And my X vector, I would like to be 180 degrees. And I'll click OK. Additionally, before I jump into the same process as a few moments ago, I want to show you that we have additional 3 parameters inside the same field. Here in the coordinate system, we have tool start level delta, clearance delta, and also 2Z level delta. As you may know, every of the machine, now we are speaking also about milling machine, we have smaller machines, we have bigger milling machines. Similarly with mill turn, there are smaller machines, bigger size machines, and also there are like Swiss type machines. None of these can take, if you have your workshop with all of these machine types and different sizes, you might not use the general settings for creating the coordinate systems. Like every coordinate system then will take huge clearances, like 10 millimeters on Swiss type, it's extremely huge. So you will probably like to make it smaller and make something more reasonable. So here I just put for my machine that this is going to be my clearances, and I'm going to show you how you can actually pull these values when creating the coordinate systems. So with this, I'm going to save this, and I'll go back to SolidCAM. I'll create the project again, start everything over. I'll accept this. I will just repeat the same thing. I will just go to the coordinate system. And this time you will see that my master is here. I'll just accept it. And now the previous settings will be ignored as the new one from the VMID will be pulled. Exactly, the data will be taken, rotating the coordinate system, actually first placing it on the opposite side of the part, and then rotating around my X for 180 degrees. And the rest of taking the stock target, it will be handled absolutely automatically. So this reduces a lot of, this speed ups your part programming drastically. So if you put all these settings, you you will need much less time to modify anything. Every of your new part that you're running under this machine will be just, taking appropriately. Now, let me go and show you another settings. If you go to the SolidCAM settings here, and there is something like CAM part and coordinate system definition, you will see here that we added a new checkbox here. In previous version, this checkbox was not available, but general settings of the coordinate system has been taken. And now by clicking on this checkbox, you can actually pull the data that is actually located inside your VMID. All right. Let me show you another thing that I believe that any of you were asking for these options, and it's connected to, let's say, any parameter that is available in SolidCAM. How many times it happened to you that you have some parameter that it's not only a logical true and false or maybe a value, but you actually have a couple of options that you would like to have it as a list. This was not possible in SolidCAM till 2025 version, and I want to show you here. So over here I have, I will just pull you up this example from the machine options, and here I have a lot of, this machine has a lot of parameters. And here I'll just pull one of the example like parameter. I know this is a lot of parameters, yeah, but I'm going to take this example here. This is one parameter, G803 is the A parameter, and it has the value of 2. Now I want to show you something, how this actually really look in a G-code editor of the Tornos. So I will just open here inside the Tornos. They have the software called Tysys. It's just, let's say, a simple G-code editor where you can modify all these parameters. And here you can see that one of the parameters here just is for each one, they have the G800, A01, A02, and there is also A03, which they actually give an option of parameter A that has a couple of options. This is the list. So they have a list of 4 options. And usually in SolidCAM, we will handle it like this is the parameter 0, then this is 1, this is 2, this is 3. But the problem with this is that the user will always have to remember what are those, what is 0, 1, 2, and 3. It was not so intuitive. So we decided to create this option for you. So let me show you how this looks. I'll just now save and exit. I'll go to VMID. Under user-defined parameters here, I will find that option there, and here it is. So this is just the general stuff that we are already all the time have it. But now additionally here, we have an option of list. So let me bring closer to you. So we have here the values list now, which has the 3 dots waiting us to be filled in. And we will just fill in the data, enter between each of these. I think this one is without, another was with. I have no clue what these parameters are, but it is what it is, type 2, and this was like non-standard. There you go. Now this will have 4 options. I can now 7 exit. I can go back to my parameters, and now here you go. Now you have a new option. I will go to the flyout window. I'll try to find here, and there you go. Now you have an option. All of these 4 are now available. So any of the posts can be modified per these. If you have any parameters that requires this option, you would like to be converted, please contact your local supplier to modify the post if necessary. This one is good. It's great. Let me show you an additional thing that I think it's great. Also, a couple of these parameters here those are strings, but here we have also kind of numeric. And in all the time, like for each either it's imperial or it's metric system posts, we always were handling, those that for each, if you want to run your, your pod under the metric, that either, so taking any machine that has the, that was the metric, then if you want to use it on inch, there were particular, if you have particular parameters that needs to be automatically converted from part to part, that was very difficult to happen. Now we created like a unit sensitive parameter that over here, for example, if you go to the numeric one, we have here the units. So we as a default, we keep the units as a general, which will just happen, nothing will happen there. But if you change it to length, any changes, if you run your part under the imperial units, it will be automatically converted to the proper value. Right, perfect. Additional parameter that I want to show you also inside of VMID, I think it's very nice, and finally we got it. We have over here an option under the working style, and you can go to the toolkit. There is an option here which we says inside the G-code output, or maybe it was here actually, pardon. So, pardon. So for the trace output, here we have the option of output a tool list. Now, as you all know, all the post developers will probably define all the output in the header of the G code, and the list was going in either in CAM tree order, or if if you ask developer to do it in ascending order, additional post changes were required. And this was the way how we were handling the things before. Since this version, we have an option that this is actually completely automatically handled. So over here, we have now an option to output not only according to CAM tree order, but we also have an option now, CAM tree, but tools according to ascending order. Now, what this also means, if you have a spindle type, so we are looking at the tool number, and this is our main ID to make tools in ascending order. But if you have linear turret or maybe a revolver turret, in such a case, we are going to take the station ID. This is now extremely very nice. So all the tools will come in this order. But now we have also here a third option. The third option is, generate all tools in ascending order. So why would we will need this option? This option, it's very common needs for the specific military machines and Swiss type machines that requires to output all the tools because of the holder description that it will go inside the G code. Every such a machine have templates or let's say the macros that will, based on the next holder, they will generate different retracts and approaches to the tool. And it is extremely important that you don't export only the tools into a G code that was actually used in the CAM part, but to actually export all of them, regardless if they are used or not, to provide the safest retracts possible according to real setup on the machine. All right, so let's jump into a toolkit. Finally, so I will, for this example, I'll just now load all the tools and show you a little bit the machine. Over here, we have now this empty machine. It's main spindle, sub spindle with the gangs over here. And I'll just load some tools over here. And I'll just do it with click here. I have already prepared this. And now we have a new dedicated icon to import all the tools to this one over here. So you can mount all the tools and all the tools will be mounted. But you can also mount it only specifically one. So we just added a new very nice icon so you can play with this as well. So the first thing that I want to show you is that we introduced a new tool, is the high feed end mill cutter. We also call it convex tip mill. And you can find it here under the milling tools. And you can just move it to the very bottom. And you can find it over here. So let me just close the machine preview and just take it to the tool viewer. I will introduce this tool. So let's say somewhere here, not really important. So if I go over here, I will just click on the topology, and inside the topology, you can see actually what this tool is actually about. So it has here the two radiuses. So I can zoom in here. So it has the radius R1 here, it has R2, and it goes all the way to this diameter. Very nice and efficient tool. This tool is also can be used on any HSS or 3-axis and 5-axis jobs. So be aware that we have actually now this tool supported. Another tool that I want to show improvements in the topology is with the end mill. So let me just jump and open any end mill. So I'll just click on this, right click, select tool component. It will highlight really my end mill here. And now inside our topology, we put here the corner condition. By default, it is sharp and the value is 0. So you can click on this and you can now put a real chamfer here. This is not meant for chamfering, but this is very usually set up to put the values that represents really your end mill. And what is the main purpose of this parameter? When you put the real conditions of your real cutter here, that will also make your updated stock correct. So you could really see the most updated stock that you will see that needs to do additional finish. And I think I have in my presentation actually a very nice picture about this that I want to show you in this webinar. And ads here exactly. So let me zoom in here. So this is the, if you put any other chamfer, you will see a true representation of what is the remaining stock. And this is extremely important to not forget those to clean it up also later. And yes, now you have it there. Perfectly. Let's go further. Finally, we also make some improvements in the cutting conditions. So if I go to the any end mill here, I will have here the cutting conditions. And I have here some default, but let me just add additional one. And I'll put here just some silly numbers, just use something to see. And maybe we can go with those. And now for the first time, you can do copy, and you can go to any other cutter, and you can paste that. So this is extremely nice, extremely powerful. You can do it many times. Not only, but you can also do multiple selections. So I can take all of these, I can now copy it, I can go to another one, I can also paste. So this is now so nice, so powerful. You can do it. You can define your cutting conditions much faster. And yeah, this is now available. Let's go further to some interesting things here too. So I will go to this holder here, and this holder is selected. So I will just go to connection, and I'll just, for this example, just break the link for a moment. Now, what we have here in the inside the connection are those fields, for the mounting, also for the joint properties. So you can see that we have set all these to the proper spot, or let's say, let me just open in Tool Viewer so you can see it better. Now, all of these now values here, they do support actually math behind the scenes. So you can just go over here and just put the number, the math, and we will automatically calculate by hitting the enter key. You need to hit the enter key, and now the math is supported in any of these fields over here. I think this is very nice, cool improvements. Additional improvements that I like to show you is that now we added here this 3-dot button here that gives you nice options. It is presented not only inside the toolkit, but also inside the machine setup, but I quite often use it here. If you click on this, you will be able to reset the whole fields here, or to reset only the positions, X, Y, and Z, or to only reset orientation. You can also do a copy. So if I now do a copy here, I can go to the mounting and I can do paste here. And all the values that you have it in this field, it can go to that field. And before this, whenever I was adding a joints and stuff and copying the values, in order to bring everything to 0, I was selecting all these fields and just click and add the zeros. It shows time-consuming process, like 0 tab enter, 0 tab enter. But now we have an option to just reset. So just reset, it will bring all the values to 0 in just simple click. So I like this one. I really, really, really like this one. Let's go further. There are some nice things in the properties. And here we added here manufacturer. We have it also in the previous versions. We added this, but we never show you actually how these can be nice and cool. You can really specify what is the manufacturer of this component. Now you can put any from the drop-down menu, or you can directly type here the manufacturer, right? Including also manufacturer catalog number. Now, if you want to affect to this given list, which is also kind of cool, you can go to view and you can go here to the settings. And here you'll find manufacturer names. And over here for individually for the cutter shanks and holders, or for the fixtures, you can add additional manufacturer name. So for over here, we can go like SolidCAM, webinar. I can save and exit. And over here now in the drop-down menu, you can also find here this over here. Now this is kind of cool. I will encourage everyone, regardless if it's the holder, cutter, or any components over here, to really give attention to this manufacturer name and also for the catalog number, because these can be very handy if you go to the advanced filter, because in the advanced filter, when you're using them, you can really define more specifically what is the cutter with a manufacturer name. So you can also go over here, find what you're looking for, search it, and it will much quicker and filter the manufacturer that you actually want to use in this case. I think this is kind of cool. We also create a new nice option here when you go to view and you jump into settings. Very often you are installing the versions from SolidCAM 2023 to maybe 2024, or you're jumping immediately from 2023 to 2025. I like that, and all these default folders are actually taking the default values, but we've seen that the libraries that our customers are using, it's usually same ones. So you want to store all the data and pull it out from same folder from which actually you're using in previous version. So now you have a kind of nice option to just load the settings, any settings that you have used, including the messages, tool type names, tool path color, manufacturer names, any settings that you have used there in any previous version. Now you can, with single click, you just load it from previous version. And I think this is very nice. I very often use this. Anytime when I install the new version, I just load it from previous version, and all my settings are adapted, including the colors and all those details. Perfect. Where we have, let's go next. I was showing you this actually holder. Let me see. Yes. Or maybe this one. Yeah, let's go with this one. I think this will be actually a better example. I want to show you a feature, and we call it custom stick out point. And yes, this is something that was requested many times in the past. Many users ask, oh, in milling we have the outside holder length, and in milling tool this is actually quite easy to define. But what about the turning tools? For turning tools, you can have very, complex holder, and it's not really clear what is the stick out point. Sometimes it goes really from the joint, sometimes it doesn't. Sometimes it's just obviously that we need to modify it. And we never had this option till 2025 version, and I want to show you how you can use it. So here I have a holder that has these 5 joints, and they are actually defined here. Usually some users will define it here in this corner, right? But still, even from defining it, both ways are okay to be defined, but none of these points actually define that this is my point from where I will define my, stick out point. For such a reason, I would show you how you can now specify what is the point that you consider that it will be very useful for your operator to get this information about. So here I have my joint, but actually more reasonably, it will be that I, measure my tool from this surface over here for each of these points. So I will show you this example on this joint over here, which will be, I'll go to my connection. I will also break the link because these are all pulled out from the library. So I want to modify all of these, and I will just break the link for this webinar. I'll click on my PA1 in this case. It's this joint over here. I want to only focus on this. Here it's my station coordinate system. And now we have introduced this button here. This is the stick out point. And now if you click on it, this blue dot here will be shown. This is the input field. And if you keep like 000, it is considered that you are not actually using the custom stick out point. It will go directly from the joint, but you can now shift it. You can shift it to any point on the geometry of the holder. This is actually very nice. You can do it in multiple ways, and one of the ways is that you can use this icon over here, which is set point. So you can go directly to specific point of it, or you can individually for each of these fields, you can directly click on the holder. So in this case, I'll just like to go along my x-axis and just click on that surface. So I'll just click on the x, just move it over here and click. I will get this value of 26. You can see that this is the dot. I'm quite happy with this. If I just move it over here, it is clear that this will be, my surface from which it will be very valuable for the operator, that he knows what is the distance that we set it over here. And I'll click OK. Right, now we define the custom stick out point. It is marked over here. You can see it here. But what is the how I can affect it? So I can click on my cutter over here. I clicked, and I can go now to the topology. And now for the first time, we added a new icon that is all located over here. So you have an icon that can control where is your tooltip, and you can click on this. Once clicked, we'll show only related coordinate systems. So not like in the previous versions where this positions actually took a lot of coordinate systems, and that was like a lot of mess. But now we actually just show you the most relevant coordinate systems here. And what we have here is we are calculating or giving you the options to put the distance that it's from the cutting point. So from the cutting point here to the distance of the holder joint. Now you can do it also opposite. You can go from the joint towards the cutting point just by clicking on this icon over here. So now it goes from, so this basically two switches. So it goes from this in the direction of X, Z, and Y towards this cutting point. You can see it with the red dot here. And you can put here the value. So you can see how nice now this is. Now let me show you another thing here. If you click here in the distance, you can also get the values from the station. So these are from the station. It goes in this direction, so all the values will be updated. But also you can see that these two are actually called the same, but this one has this asterisk symbol. Asterisk symbol means that this is actually the joint, yes, but when used the stick out point, and it goes automatically there. If the custom stick out point is not used, then it will automatically be this, and this one will not be even listed. This is kind of nice. You can also access this data if you go to the connection, and you will also find it over here, set position, the same input you can also provide over here. Right, perfect. There are three more features that I want to show you in the toolkit. And one of these is auto-locate model component. And I like very much this feature. Let me show you what it's all about. Over here, I have, let's say, this rotary. Let me just reload this component so I get all the, and restore the link and just reload the component. There we go. So this is my holder here, right? You can see that it's linked, and it's linked towards this database here that I have. And yeah, that's fine. And in my organization, I know that how I'm storing all my data, and I'm very organized person, so I know what is my structure, the folders and stuff. But sometimes I have a need to reorganize the folders, or maybe change the name of the component inside my library, and that will actually break the link that I just now showed you. So I will just go to my topology and tell you what it's all about. So you can see here direct connection where this file has been stored. And I can now, just for now, in order to access this, break the link and just click on these three dots so I can show you where this is located. It is right in this folder with this specific name, and I can just now copy this, and I will open it in Explorer. And this component, it's called this one. Yes, exactly. So here it is. I like it. But what will happen if I now maybe rename the file? I can maybe rename the file, or maybe if I change the path to it. So I will cut it. So I'll use option of cut, and I will create it, in some other folder. This is very typically happening, that you move the files, you want to reorganize. It happens, or maybe if you have more people who are organizing your data, then it can happen that some files will be just simply destroyed because you don't know what your colleague did. So I just now move this file over here, right? So let me now just leave. Should I save or should I not? So let me just I'm not sure if I save these all components, but I will just now restore the link and just save it and exit. Okay, so if I go now back to the toolkit, once I reopen it, I can now just remember that I am now inside my TLP, or toolkit that is in part. So my STLs are stored in the part. So that's completely fine. But now if I just select this tool component, you will see that now we have this icon over here nearby. Something is wrong with the link towards this file. Let me just exit from the toolkit, and let's go to my tool components. I will open this bonus library, and I'll go to my GT32 gang, and it's located over here. Now when I click, you can see what is happening. I have this icon here, but also my tool viewer is now showing no data. The joints are there, but there's no 3D. Why? Of course, because there is no 3D model. We actually move this folder and we break the link by doing this. So how we can restore the link? Usually way of doing this was just by clicking on this. In this case, it's easy because I know where this file is. And doing it that individually for each component, it's crazy. So I can go here new and just relink it, and it will be just fine. Yes. But now you have an option of doing a right click, and you have here an option auto locate. Once you click on this, we will automatically insert the name of this file into this field and give you all the options. We've searched all your library where this file actually is located and provide you a new option. It can be that you will have more of these. Sure, it can be also that nothing has been found. In that case, you need to try to find a different name. So you can actually just type specific component like so. I can click on search, and you can see that he again found only this one. So it's perfect. I will just now replace it, and now my 3D of this folder has been recovered, and I can save this data and enjoy it. I really like this feature. In the future, we have an options or the vision that we will do it on whole library, so you don't need to go like individually like this, but I think it's kind of cool. All right, so let's go to another one. You've probably seen it, that I was doing the right click here. We have now Faceted Model Editor. I hope you are familiar with it because you can run it only from the CAM part while the CAM part has been active. By right click on the CAM part, and you will see in the drop down menu there is the Faceted Model Editor. Hopefully you are all familiar with the Faceted Model Editor. If you're not, there will be a video in our e-learning platform. You will learn everything about Faceted Model Editor. I will cover all the details there. For now, in this webinar, I'll just show you how you can activate it through the toolkit. So for this particular STL, I can do right click and open it in Faceted Model Editor. He will automatically open it there where I can shift, rotate, merge files, separate them, move, and etc., and save it as another individual STL. I can do it also on that one, but also you can find the Faceted Model Editor under Edit, and you'll find it also over here. Now, why the Faceted Model Editor is also important and to be placed on the side of the toolkit, because the toolkit is offline application. Remember, the SolidCAM, the Faceted Model Editor, you can run it only while the SolidCAM has been activated. I mean, while you are either in SolidCAM for operator or maybe inside the integration, but this is a breakthrough. Now you can just open the toolkit and open the Faceted model editor through the toolkit. You don't need to actually really open it from SolidCAM itself. All right, and another feature that I want to show you is the improvements that we have done on the level and import from CAD. I'll just now here exit, and I prepared here this holder example. I think it's very nice, very simple. I show it in some of my earlier webinars. I very much like to use it. And as you can see here, this is the assembly where all my data related to coordinate systems has been ready. So I have the holder, shank, extension, and also the cutter itself, and all the details has been prepared. Now, if I really want to use some of the holders, not in this milling example, but if I have very advanced like 4 or 5 stations holders and stuff, I really need these to define all these coordinate systems, and importing from CAD was never for me an option. And I'll show you now why. So while this is open, I'll just jump to my project, and I want to use this import from CAD option. And before using it, ensure that this window is active, and I will go to window and just select it here. There we go. And now I will, while this is in the background, I'll now just click on this, import tool assembly from CAD. Is this the right one? Yes, just click OK. Okay, so what we have done a couple of improvements. So we put here the resolution. We also create like coordinate system, general system input. So you can now get all the coordinate system right data. So I can directly say what is my coordinate system, and I can now generate as a milling tool. Here's my milling tool. This is nice. This is good. I can, of course, now convert other components and etc. And usually in the previous versions, if you really don't care about saving all of these details or components individually to your vault, normally you will just click OK and just do a drag and drop to any level. I don't care in this case. And I will just use this and just let's pay attention to some of the details. If I go to this components, we can see that every component here have the coordinate system that is right here. If I go over here, all the data of the mounting has been 0. Also, my joints has been 0 for each individual component. Now, this is not so good because what if I want to any of these components use with other assemblies? In this case, having the coordinate system here, actually, it will be pretty bad option to have because I will need to shift it manually in the correct spot. And I don't want to do that. So let's click again and let me show you another options. So I'll click on the holder here and I'll generate as a milling tool. And now we have for each individual component, we can now, okay, we can see here what is the size of this, and we can, for each individual component, we can see what is the size of particular component. And for example, for the holder, I can also change my resolution. So generally for all my components is this data has been taken, but for this one, maybe I want to take even more rough definition. So I'll click OK, and only for this component, I can actually now use this. But maybe for my cutter, I would like to go with more details. Perfect. So this is the first thing that now I can say I would like to use this one from now on, but still not enough because I want individually to control of my coordinate system. And now finally we can do it. For each individual component, I can now change my reference coordinate system. So this one will be for the first, this one will be for my shank, for my extension, and also I have my for the cutter. And once done like this, I can click OK. I can also do a drag and drop. And let's see now these changes. I have here my coordinate system. I can see it over here. I can see that my coordinate system is also there. I can see the coordinate is there, but something is also odd here. You can see that my mounting actually has been shifted. So I have some values here that it's shifted all my coordinate system positions here. And what if I will just put here all to 0, like so, and if I use here the focus mode, you can see that actually all my components get to this same point. So in other words, every of these components can have automatically joined in the proper positions. And I never had this option in earlier version. So let me show you the third way of doing it, which I think you will use it at most. So I'll again click on this import from CAD. And now I will just repeat the same, import as milling. I will say that this is my holder. I will change this is my shank. This is my extension. I'm doing it a little bit quicker than earlier. And now we have an option that I wish that my holder here takes and generates the joint regarding to my component coordinate system here. So let me show you what I mean about it. So here I see the coordinate system of this component, and I would like that my holder takes that as a joint. You can do a right click and here use this option, auto offset joints. This option is individual per each component. So you can see that if I do now right click on that component, it's checked. If I do on this one, it's not checked. So I will do for each of these 3 components here, and I'll click OK. And now let's see the end results. I'll just put it mounted to the free station. Here it is. It looks at everything exactly the same, but I have now for this component, I have my coordinate system of the STL is here, but automatically my joint is here. In other words, my second component here, it has all the values 0, but all the joint is properly defined. So my coordinate system is here, but my joint is here. Then for the next component, my joint is here. And finally, for my cutter, the joint is here. I believe that now this is, now with this, I'm using this, this import from CAD saves me tons of time. I have so much freedom about the resolution. I can influence to where my joints will be. This is great. And you can do it also for the milling, turning tools, but also for the fixtures. All right. And the last topic for today, it will be about the MCOs. And we have introduced to you a new option, how you can actually make a movement. It's another breakthrough. I want to show you first the issues that we had and how we actually solve it with this feature. So in this case, I will close this project because I have the same one with define all the CAM parts. So I will just use this one. And the best way to show you this feature is actually to go into the part transfer routine. And as you probably know, this is on the, we start on the very Swiss type on the main spindle, and then we have a routine where we say, or taking the MCO, where we are going to extrude our part to the cutoff location, take the cutoff tool, and pre-position it in Z and X. So let me show you how this MCO looks like. So it's over here, and it has very minimum data. Just select the cutoff number, cutoff, take the Z1 position. So the part is 50, exactly 50 millimeters, and we just to give a little bit of extra. And we go in diameter, we go 24. So let's see where this actually is. So I'll go into my machine preview. This is my previous location, but let's now update it, what's happening over here. So we take the cutoff, we are on 50.2, pardon, and we go on 24 in diameter. As you can see now here, this is the output. This was actually completely okay. I mean, all our machines, regardless if it's the milling, mill turn, or Swiss, we found a way how actually we can replicate and do every very nice MCO cycles. But I want to show you something where we have actually improved some things. So I will just, instead of showing the cycle, I want to show you something inside our general, how this actually has been built behind the scenes and how this can be actually improved. So over here, we have an item that it's called the submachine item. We have here the submachine, and every time now we can drag and drop the submachine into these actions. But for now, I'm going to take the one that is responsible for these movements. And let me show you this. So this is exactly what we actually said here. Along the Y, it will be 0, and we will put here on 50.2. Here we have the indication, it's the parameter that will be shown in that parameter list. And this is it. It works pretty good and pretty well. But here we have the mode, which is the part coordinate system. But what mostly you as a user confuses is that everybody thinks that if you want to be related to in the part mode, that you are actually related to your G54 offset on the machine. But this is actually not true. Where you are related to, you're related to your part coordinate system. Actually, the master MAC that you can actually see it over here. So this coordinate system doesn't take any information about the machine kinematic at all. It doesn't take any submachine coordinate rotations. And therefore, in order to get correct output, as you can see it here in the visual, we actually use here something that we call the dummy rotation, where we, if this is the C0 here, in order to get orientation of our MAC in this direction, we actually use the dummy of rotation of 180 degrees that you can see over here. And only once this is rotated, we can actually get the positive output. But let me show you what will happen if here we will put here a 0. So the coordinate system is actually here. I will tell you what will happen. The coordinate system here, it will go, the cutoff will go in the wrong direction. So if I go here and just go to the X submachine, you'll see that my cutoff tip, it's 24 indeed, but in this coordinate system. So you are just fine if you are using, all our MCO cycles. Just continue using that, but they can be improved by using the VCS, WSS, or the Workpiece coordinate system. It is exactly the same coordinate system as so far, but with the main difference that it actually takes into account the whole kinematic, okay, like a real work offset on the pod. So how you can switch that? You can do right click here, and you have now an option of swap to the work mode, we call it work coordinate system, or you can just double click over here like so, and it will change the coordinate system as you can see it here. The same, we can do it over here. If I double click on the mode, it will be the coordinate system here. And now, regardless of what I'm using here, the part orientation of C or 0, I can just simply remove this. I don't need it anymore. I can go over here and I can enjoy that every single time my work MAC will be taken into account regarding to what submachine actually has been used on the machine. I hope you like all these features. This actually covers all the features that I wanted to show you in this webinar. I hope you like it. If I will give you 1 minute clearance to ask me any questions if there are. Let me just quickly check it. Over here. Yeah, okay. So the part and the presentation, I didn't show you the presentation because I'm more like the person that like to show everything in the software. So yes, we will share you also the PowerPoint presentation, so you can see more or less all these features in the PowerPoint presentation. But I will also send you individually all these CAM part, also the toolkit, so you can play around and see all these features that I show in this webinar. I see no further questions. With that being said, being checked, I would like to thank you for your attention, and we'll see you in the next webinar, part 5. Thank you very much.